So today we will be able to solve radical equations and identify extraneous solutions for all radical problems. And in this case, we're going to show you how to do this, or I'm going to show you how to do this, by using the square root of x plus 7 minus 5 is equal to x. Okay? So let's go ahead and begin. So let me here zoom in. Okay? So the original problem is the square root of x plus 7 minus 5 on the outside is equal to x. Your first step is to isolate the x, or the square root of x plus 7. Okay? So for us, this means that we have to move this square root of 5. And that's exactly what I'm going to do next. We're going to add 5 to both sides of the equation. And when we do so, we still get the square root of x plus 7 is equal to x plus 5. Then our next step is to take the square of both sides to cancel out the radical. Okay, that means that we're going to go back, we're going to square the left, and we're going to square the right. But be careful when you square the right because you're squaring a binomial, okay? And whenever you square a binomial, you have to remember to FOIL. So I'm going to do it here in the corner. Okay, x plus 5 times x plus 5. First times first, x squared. Outer times outer, plus 5x. Inner times inner, plus 5x. And then last times last, plus 25. So, on one side of the equation, the square root and the square cancel each other out, only leaving the in radicand. On the other, we're going to have x squared plus 10x plus 25. Now, steps 3 and 4 is to simplify and solve for x. Now, in this, normally that would involve isolating x, but in this case, since we have a quadratic, the process is slightly different. We're now grouping everything that has an x, or everything in general, on one side of the equation, so we can set it equal to 0. And that's a special case whenever you're using quadratics, or any type of higher order polynomials. That means we're going to subtract x from both sides, and I'm going to subtract 7 from both sides of the equation. When we do that, you're going to get 0, which is what we're looking for. X squared plus 9x plus 18. Since we set everything equal to 0, our next step is to factor. Okay? Okay, so how we're going to do that? Well, if you remember back when we did factoring, you should remember that we need two numbers that will multiply together, give you 18, but added together give you 9. And the best way to approach this is by looking at the factors of 18. If you know the factors of 18, you just have to make a list. Okay, so I'm going to write it here in the corner so you can see. The factors of 18 are 1 and 18, 2, 9, and 3, 6. Okay, we're looking for one of these three sets that adds up to 9. 1 and 18 gives you 19, so that doesn't work. 2 and 9 gives you 11, so that doesn't work. And 3 and 6 gives you 9, which is what we're looking for. So in this case, we know that it's going to be 3 and 6, 3 and 6. Okay, the way that we're going to use this is that both of them are going to be positive. Great. And since there are two of them, we need two sets of parentheses. That means we're going to add a plus 6 on one of them and a plus 3 on the other. Now remember, we still need x's inside of those parentheses, so we need to write x and set it equal to 0. Once we're done with that, just remember that we have to set each individual factor equal to 0. So on one hand, we have x plus 3 is equal to 0. And on the other, we have x plus 6 is equal to 0. Solve for the x, and you get x is equal to negative 3, and x is equal to negative 6. Now, step number 4 is probably the most important step that you need to do in this process, because sometimes the solutions they get don't always work. What you're going to do next is you're going to check your solution. So let me write the original problem. We're going to plug in the solutions that we got into the original problem to check that they work. So we have x plus 7 minus 5 is equal to x. And I'm going to write it twice because I'm going to plug it in twice. So we're going to plug in -3 and -6. Let's start with -3. So on the -3 side, we're going to have square root -3 plus 7 minus 5 is equal to -3. Our goal is not to move anything and simplify the left-hand side, and it has to match the right-hand side. We're going to get the square root of 4 minus 5. Okay? So you get 2 minus 5, and you get the -3. It is indeed equal to -3. So we know that the -3 works. We're going to do exactly the same for the -6. Okay? So at least we know that one of the answers, x is equal to -3, works. So let me actually circle it so we know that this one works. So that we have double checked that one. Now let's look at the other one. For the other one, we're going to do exactly the same process. Plug in -6. So -6 you get the square root of 1 minus 5 is equal to -6. I forgot to put the -6 here. Okay, so we get 1 minus 5, which is -4, and that cannot work. Okay, so we know that 6, x is equal to -6, does not work. So our correct answer is, let me write it over here, x is equal to -3. Okay, and that's what we call checking for extraneous solutions. When you look for a problem, solve the problem, and just double check that both answers work. And it's very common to see it when you have two answers. Okay, sometimes both answers will work, sometimes one of them will work, and are even cases in which none of them will work. Okay, which is what you have to be careful about. Okay, so go ahead, we're going to stop right here and go ahead and try the problems on the right. Now, a few things that I want you guys to remember. Okay, if you have a rational exponent, it is exactly the same thing as having a radical. Okay, it uses a similar process. Okay, and if you want to, you can convert it back to a radical to make it easier on yourself to solve. So for example, on the top one here, it's the same thing as having the square root of 5 minus x is equal to x plus 1. Okay, same thing for this one right here. Same thing as having the square root of 5 minus 4 minus x is equal to 0. Okay, so go ahead and finish those for homework. Okay, and we're going to continue on to the next lesson. Now what we're going to do is solve radical equations with two radicals. Now the idea behind how to solve these is to isolate the most complicated radical, solve that first, and then continue on with the least complicated radical. So let us begin. Let me rewrite the equation. So our first step is to isolate the more complicated radicals. So the more stuff you have inside the radical, the more complicated it is. So that means that we're going to isolate the square root of 2x plus 1. And we're going to do so by adding square root of x to both sides of the equation. That's going to give us square root of 2x plus 1 is equal to 1 plus the square root of x. Our next step is to square both sides of the equation. Now, when you square both sides of the equation, one radical has to go away. That's the reason why we do it. And the one that's going to go away is the more complicated radical. In this case, it means that the square root of 2x plus 1 is cancelled out, and we're only left with 2x plus 1 is equal to. And then on the other side, notice that we have a binomial, all right? 1 plus the square root of x squared is 1 square root of x times 1 plus the square root of x. So always remember that this is a case in which you FOIL. Okay, so you get 1 plus the square root of x plus the square root of x plus square root of x squared. Okay, simplify that. You're going to get 1 plus 2 square root of x plus x. Now, in this case, nothing cancels out. They just simplified. Okay, so we're going to write 1 plus, I'm going to put the x in the front to make it easier on myself, plus 2 square root of x. And we're done. Now, notice that we still have a radical, okay, the square root of x. What we're going to do next is exactly what we did before. We're going to isolate that radical, okay, until we only have the square root of x on one side of the equation. So let's go ahead and do that. So in order to isolate this, what we're going to do is we're going to add 1 to both sides. Or actually, my bad, it's supposed to be subtract 1 from both sides. Careful about that. And we're going to subtract x from both sides. When we do so, it simplifies to x is equal to 2 square root of x. Okay, because the 1 cancels out, the x cancels out over here, and then 2x minus x is equal to 1x. Then we're going to go back and divide both sides by 2. Okay, that is going to eliminate this 2 over here, and you're going to have x over 2 is equal to the square root of x. Then, like before, we have to take the square root of both sides of the equation for step number 4. So, we go back and we take the square of both sides. Now be careful with this one, because when you take the square of both sides, that means the top and the bottom of the radical. So on one side, you're going to get x squared over 4. On the other, you're going to get x. What you do next is you're going to multiply both sides by 4. So we don't have a fraction, so we get x squared is equal to 4x. And then we're going to subtract negative 4 from both sides. Now we do so because we have a quadratic equation. And whenever we have a quadratic equation, it usually involves setting n equal to 0, factoring out. It usually involves factoring out and solving for x. So we get x minus 4 equal to 0. And you get that x is equal to 0 and x is equal to 4. Now, like before, you always have to remember to check your answer. So for step number 6, we're going to go back and check our answer. So let me actually make a little square over here in which we check our answers. So check. So the original problem was 2x plus 1 of the square root is equal to 1. Okay, we're going to plug in 0 because it seems to be the easiest one. So the square root of 0, and then 2 times 0 plus 1 is equal to 1. So we get here the square root of 1 minus 0, which is 0, so I don't need to write that. Is equal to 1. And that works. So we know at least the first one, x is equal to 0, is going to work for our scenario. Now let's double check the second one. For the second one, we're going to have 2 times 4 plus 1 on one of them. Square root of 4 on the other one is equal to 1. This is 2. 2 times 4 is 8 plus 1 is 9. Square root of 9 is 3. Okay, so 3 minus 2. And look, both of them work. So this is one of the cases that you have two solutions instead of one, okay? But you always have to make sure that you actually double check both answers, okay? Because you have to check for extraneous solutions. If you don't, remember, if this was a multiple choice test, one of the multiple choice tests will have the two answers and the other one only have one, okay? So remember, what we did today is we isolated the more complicated radical, okay? We solved for that radical by taking the square root of both sides. And once we isolate that radical, we're going to isolate the leftover radical, okay, and we're going to repeat the process, okay? Once you get the solutions for x, what you're going to do next is check for extraneous solutions, all right? Please, what I need you guys to do is go ahead and try the practice problems, okay? So you're going to try these first two. Remember, doesn't matter if you have a rational exponent, it means exactly the same thing. So for example, in cases like this, in which you have 2x to the power of x, just remember it's the same thing as the square root of 2x and the square root of 5 plus x. It means exactly the same thing.